I assume y'all saw the president's note that we're going to run this till January 31st, I guess, till the end of January. So it's going to be online at least
for Zoom.
Yep. That will be a bit of a pain, but we'll manage to get through it. So I'm checking right now to see how many people are supposed to be enrolled in this versus how many are in the actual class, because I set it up initially for us to have the same lecture person as you have for lab. But that seems to not be the case. The DO1B might have the same students. So are all of you folks in my class that just met, the lecture that just finished at 12:20 roughly?
I am, yeah.
Yeah. Anybody in here not in that lecture? So instead of 15, we only got 12 now. So anyways, it seems like all of you are actually in that lecture, so that's good. You've already got your syllabus. We went over that in the first day of lecture, which should be on the first day of video, which evidently I did not post. No, that was 241 I didn't post evidently. So that should be up there. I should really go back and edit out that phone number and stuff, but I probably will never do it. So anyways, but remember, you are allowed to email me. I suggest you email me from your TCC account, not from Canvas. I'm probably never going to get your Canvas email if you email me from Canvas. Make sure you start your subject line with either 242_D01B for lecture questions, or 242 L01B. Or you can actually say 242 just lab, 242 space lab. That'll be fine. You don't even have to do the lecture number. Just give me the lab part and that'll find it. But it doesn't matter if you're asking a lab question and you put the subject line for the lecture. That's not going to bother me. So either one you remember will be fine, as long as you put one of them to start it off with. Anybody have any questions on anything whatsoever, how the course is going to be run, how the grades work, that sort of thing? Did any of you have, I know Jessica did not have me last semester. Aaron Brown and Brian Jones and Chris Cardock, they might not have. Did those of you that didn't have me last semester, did you have a TCC lab last semester? Oh, you did, Aaron, thank you. I told you I'm horrible with names. Okay. The reason why is this first lab is like the world's easiest lab. It's just a review of what you learned in like lab 4. Oh, you transferred from a different from another university. Okay. So what we're going to do is we're actually using Excel as a data manipulation tool. So it's a tool that can take data and find a line of best fit. It can find a curve of best fit, and it does so by doing a least squares fit, which is quite a involved algorithm that you have to follow. So you might have a little bit of difficulty doing this if you were at, for instance, another school last semester, but you might have actually had something very similar to it in high school or at your other college. So this first lab is just a refresher of that to learn how to actually manipulate data in Excel. So all I'm going to do is I'm going to create breakout rooms. It looks like we're only going to have 12 people. So I'm going to make 4 breakout rooms. At most, we should have 15, and then that'll have some people having 4 and other people having 3 to a group. So even if other people shows up, that's what's going to happen. So let me first off start by sharing my screen. And I'm going to go, I'll go to here. Not because I wanted to go to here, because I actually wanted to go to here. And then I'm going to go to modules. And this I'm going to not collapse. So there's a Zoom meeting. That's the Zoom meeting from last semester. So I got to erase that real quick. I'm going to do that now before I forget and make a fool of myself. Okay. This is the last semester stuff too. So I'm going to delete that. Now, here's the Google Docs stuff. These 2 syllabuses do not matter because they're from last semester as well. And this list of YouTube videos is not up to date. I'll put the new up to date one there now, or I'll do it sometime during lab probably. So I'm going to erase that one. But this is the link to my YouTube channel. Again, you can do that without the /C in there. It can be just .com/Billy Younger Physics Solutions. And this is actually to my Google Doc. So each day I take the photograph of the pages that I write for notes and I put them in here. And you can search them by date. I usually use 2-digit month followed by 2-digit day followed by 2-digit year, but sometimes I'll use 4-digit year. So if you just do the first part of the date, you'll be able to see what I'm doing and just do a search that way and you'll find the documents. Don't be afraid if you find another PHY 242 that isn't D01B, like if you find an N05B or something like that, don't be afraid to use that one, because often, in fact, the N05B does what we do, but they usually do it a day before. So sometimes you can get that information beforehand. And once we go back to class, which hopefully we're going to do eventually, I might not be able to put them up on YouTube anymore. So you'll just have access to the new N05s as well as to past semesters. So you can search for those by just looking for 242, since your class is 242. You can search for them by looking for 242_D, because that would be one of the labs, one of the lecture sections. You just don't want to do a search for 242_L, because that'll be the lab sections, and I hardly ever record anything on those. Now I'm going to go back to here. Somehow we got week 3 up here, 4, and 1 is not, and I don't know why. That's not it. Why did week 1 not appear? That is...
For some reason, it's labeled as week 2.
Is it? Okay, there is week 2. And okay, that might have been, oh yeah, and it is spreadsheet review. Thanks. I didn't even see that when I went by the first time. Okay, yeah, for some reason it's labeled as week 2. That might have been because we had to miss class or something weird like that. So this is what we're doing, the spreadsheet review. I'm going to go ahead and open this up and show it to you. And there's no changes to this. So sometimes you'll see this up here, and this is actually the document straight out of your lab manual. So you've got to make sure you buy your lab manual. I've got to verify that you've bought it. And then probably next week or the week after, I'll have to confirm that you have it, or you'll have to be dropped from the course, because I'm not allowed to put these up unless y'all have already bought them, because, copyright issues, that sort of thing. So I want to make sure everybody buys your lab manual. But this spreadsheet review is just using Excel. And the way Excel works is you have cells that have row numbers and column numbers. The row numbers are actually numbers, 1, 2, 3, 4, 5, but the columns are actually letters. So the first column is A, the second column is B, third column is C, so on and so forth. And then the first row is 1, second is 2, third is 3, so on and so forth. So if you wanted the first column, first row, you'd type in A1. And it'll do that. But then if you take that formula that uses that A1 and you copy it downward to the next cell below it, then that'll read not from A1, but from A2. If you copy it to the right, it'll read from B1. So weird stuff like that. The way you keep it from doing that is you put a dollar symbol in front of the A and in front of the 1, and that tells Excel, hey, continue taking it from A1, even though I'm going to copy this formula down a number of rows or over a number of columns. If you just wanted the row to stay the same, then you could just put the $ in front of the 1 and let the A just stand by itself. Then all the individual columns would change, but the row would always be row 1. So that's kind of nice, but that allows you to do things like you could program this formula in where your certain box is going to give the answer V, and it's going to go back and get V0 from, say, A1, and then it's going to get G from, say, A2, and then B5 is going to actually have the time in it. So maybe your column B has 0 seconds, 1.5 seconds, and then 1 second, and then 1.5 seconds, so on and so forth in the B's. So then you could put equals $A, $A, $1 plus $A, $2 times B1 in row 1. and then you copy that down, and it'll automatically put in B2 for row 2, B3 for row 3, B4, and then B5 for row 5, so on and so forth. That's the way the spreadsheet works, and allows you to do a lot of quick calculations easily. It also allows you to check your kinematic equations, like if you're just learning how to do the algebra, which you guys are calculus-based physics students, so that shouldn't be a problem. But if you're still a little rough on your algebra and sometimes make careless mistakes, you can sometimes just program them into an Excel spreadsheet and just, you know, have it plug it out every time, so you can actually calculate the answers and verify that you're doing it correctly. So it goes over graphing basics, which says to graph the data, place the X data in this. So what I'm going to do now is I'm going to stop sharing this document. And somehow I pulled you guys down here to the bottom. I want you up here. Okay. So I'm going to stop sharing this document, and I'm going to open up a Excel document, which I actually have one open already. I have no idea what it is. That's all. It'd be exciting. Probably my grades from last semester with everybody's names and social security numbers or something. Nope, I got lucky. It was not that. So I'm going to do file, open a blank one, and I'm going to show you how some of this stuff actually happens. And then I'll share that document with you once I open it up. Kill this one. Okay, so now I'm going to share document. And the document I'm going to share is this one. Okay, so what we're doing is we're going along the same sort of process. And what I'm going to do is just show you how you could do something. Well, let's, oops. I just got my own screen in my way. Okay, so let's say we have some acceleration, some initial velocity. Let's say that the initial velocity is your lab manual, I think, was doing A1, and the other one was A2 or something. So let's say V0. I'm just going to call this V0. And then next to it, I'm going to write what A0 is. I'm going to say it's, actually, I'm going to let it do some math for me. I'm going to say 9.8 times 3. Okay, just because I would really rather use 9.8 instead of 10 for the gravitational acceleration. And 10 is what we use when we're like doing that conceptual course. And if I have a multiple of it, the numbers will come out really neat. So now I'm going to have G, gravitational acceleration. I'm going to say this is actually in the downward direction. So I'm going to call it negative 9.8. Put that there. Now what I'm going to do is I'm going to create a column called time. And maybe I'll put it here. And like I told you before, numbers are meaningless in the sciences unless they include their unit, or unless they are unitless, then you don't include their unit, of course. So I'm going to say this one's 0. And I'm going to say this one is equal to, now notice what I do. If I just click on this box above it, notice that is box D2. If I just click in there, it says D2 for me. So it automatically knows to fill in that D2, and I'll say plus 0.5. So that one gives me that. Now, if I take that formula and drag it down, look what happens. It does the same thing everywhere. So I'm going to go for maybe the first 20 seconds, or actually 9 seconds. And let me do it. Let's go ahead and go to 10. Okay. So that's the time. Now what I'm going to calculate is the velocity. And that'll be in meters per second. Okay. Well, according to the formula that we were just looking at, that's supposed to be equal to V0, which should be $A, whoa, $1. Notice it doesn't care about, whoa, it definitely cares about the difference between an @ and a $. It doesn't care about the actual case of it. So I'm going to say V0 plus G times T. I'll say plus G, which is $A, $2. And now I'm not quite right. I still have to say times, and I use the shift 8 for times. And now I'm going to say this number. Notice I did not take the time to put in my dollar signs because I want, when I copy this down, I want it to take the next time. So you see here, this says D2, which is that box there. When I pull it down, that's going to become D3. So it's going to pull on that one. And this one's going to be D4, and it's going to pull on that one. So that should work. Now, it might be too big to fit in there. So sometimes it'll say something like that. Or sometimes I've made some kind of mistake. Let's see what's going on
But
here. Let's see.
What you've done is you said A1 and A2, but those are your
Oh,
titles,
thank you.
not the numbers.
Thanks. I appreciate that.
They need to be B1 and B2.
Yeah, thank you. I appreciate that. Yeah, I completely forgot that that's what the manual was saying, not where I actually put them. So yeah, now I did that. Sorry about that. So everybody see now, by putting those dollar symbols, it repeatedly sends me back to the right place. Well, now that I put the right letter in, and then it sends me back to the right place again for this one. Now, if I pull this down, it'll say D3 in the next line, D4 in the next line, so on and so forth. So I can tell what the velocities will be for the first 10 seconds in increments of half seconds. Okay. So that's kind of nice. That's a really cool feature. And that's something we could actually do to predict, for instance, the velocity of a projectile thrown straight upwards at any time if it had an initial velocity of 29.4. Now, what we're getting is actually just the y component of velocity. So I'm not even doing a projectile. I'm just doing a ball thrown straight up. But I can also use another kinematic equation, which is for the position as a function of time. And this will be measured in meters. Now, this equation is 1/2 AT squared plus V0t plus x0. So what I'm going to do here is I'm going to say x0. And I'm going to say that is, in fact, let's call it 100 meters. So this should be written as x0 in meters. This G should be written as G in meters per second squared. And this one should be just meters per second. Like that. Now, the formula here is x equals 1/2 AT squared. So I'm going to say 0.5 times A, which is this G. So I'm going to do $B, because I'm no longer an idiot. $2, again, hopefully because I'm no longer an idiot, times T squared. So I'll put in this, and then I'll square it, and your Excel actually knows what that caret symbol means. Now I'm going to say that's the 1/2 AT squared term. So I'm going to say plus V0 times T. So my V0 is B1. So I'm going to say $B, $1. And then I'm going to say plus X0. And that happens to be $B, $3.
Do we need to be putting this on our lab, Professor?
No, I'm just giving you an example. Your lab is going to be basically doing something very similar to this, and I'm just showing you how it works. I will email this to all y'all if you want, so you can have it if you want to look at it. But the main thing is you're just going to understand from me doing this how this works. So what we do now is copy that formula down, and that'll give me the position. So what I'm looking at here is sort of like I had a particle that I'm throwing straight up, but I'm on the edge of a cliff. And my hand, where the ball is released, is at 100 meters above the base of the cliff. So what I'm finding out, I'm wondering why that doesn't say 0 for my, I did B2. I did D2 for my time, D2 squared. Oh, there it is. Notice I forgot the times time here. There you go. Now I got to copy that formula down. So now what I've made is a graph or a statement of values of position as a function of time. x, and a velocity as a function of time, v. And this is exactly what you predict for projectile motion or for an object thrown straight upwards. Now I might want to make a graph of it and then try to curve fit it. That's the nature of what you're learning from this spreadsheet lab. So what I'm going to do is I'm going to insert. Notice I clicked on insert. I'm going to click on this right here. See that says the XY scatter plot. I'm going to click that. And then I'm going to click just the dots. You never want to connect the dots in a lab. Okay. You want to find a line of least squares fit. And then you want to tweak that and find out which one gives you a nice line or whatever. And then from there on, you forget the data points. You always go back to the actual equation. Now, in doing this, I don't have any idea what Excel thought it was doing. It might have actually correctly taken my time and put it on the horizontal axis and taken my X and put it on the vertical axis. So what I need to do is check that. Well, I got that data point right there, and it looks like it's doing sheet 1, which is this sheet. It's doing $F, $2, which is my y-axis. So it is actually taking my x of t, and then it's doing down to $F, $2. So it just took that column and it's plotting it all versus looks like it's not even taking, it's probably just taking counting numbers. It looks like it's taking 1, 2, 3, 4, 5, 6, which is pretty good because it's still, you know, sort of the same order here, but that's not what I want. So what I got to do now is change the data. So let's say this. Oops, let me move it over here. This will usually allow you to decide the series that you're going to do. And my people cam is in the way. So what I want is my X values. My Y values is F2 through F22, and that's fine. But what I want for my X values is D2 through D22. And now we hit OK. Now you can see that graph looks almost the same, but notice the first point is X equals 0, Y equals 100, which is exactly what we expect it to be. Okay, so now I've got that. Now what I can do is I can add a chart element, and that's going to be a trend line. Can y'all see that little window that says chart element? Or is that outside the window?
We can see it.
Okay, so this says trend line. I'm going to click on that. I'm going to click here, and I'm going to say more options. This is clearly not a linear graph. You can tell that, right? So what I'm going to do is I'm going to go to polynomial. And just for the heck of it, I know it's second order because I just wrote it as a second order. Let's do 3 and see what happens. Okay. You can also do things like you can set the intercept, and you can do stuff like display the equation on the chart, which I definitely want to do. And you can display the R² value, which is a measure of how good your graph is or how good your fit is on the chart. I did that. Okay. So now I have that. I'm going to get rid of this right here because I don't even know why that showed up. Whoa, let's do undo. Please undo. Okay, yeah. So notice what happened. It actually did a curve fit, and it got an R² value equal to 1. That's the best case scenario. If you get a perfect 1, that means it fits essentially perfectly. The closer you get to 1, the better it is. So 0.9999 is really good, or 0.995 is a little less good, but still really good, right? And what it found was the leading coefficient of the time squared term was negative 4.9. Well, we said it was negative 1/2 G. So half of G is 9.8. Half of that should be 4.9. And you can see it is negative half of 4.9. We also said that it's V0 times T is the linear term, and our V0 is 29.4. So it nailed that. And it said our X0 was 100. So it nailed that. And notice how smart it was. Even though we told it was a third order polynomial, we told Excel that it was a third order polynomial, and it tried to do that. And the only way it could do it was if it used a really, really small coefficient for X cubed. And that coefficient is in fact a decimal point followed by 14 zeros followed by 7. So you can see it, he's even smart enough to realize, no, this is not a fourth order polynomial, or not a third order polynomial, excuse me. So that's the way you can do this kind of stuff. Now I can do another title where this one will be linear, and that's normally what we use more often. So what I'm going to do is now insert another one, another scatter plot. And I think this time, actually, let me do this down to 22. Actually, let's do this. I'm going to do time all the way down to 22. And now I'm going to do insert scatter plot. Now it looks like it did something wisely. It looks to me like the time equals 0 is about 29.4. And in fact, notice hovering over it, it says 0, 29.4. This one should say 0.5, 24.5, and it does. So if you actually select the X column first, and then the Y column, highlight those first, like I just did, and then hit insert, it'll automatically put the equation in the right way that you want it. So now I have to do is add a chart element. I'm going to add a trend line, and this time it's going to be linear, but I'm going to do more options. So I want it to be linear. I do not expect this to have, well, yeah, I do expect it to have a intercept, but I don't expect that intercept to be 0. So I'm just going to let it choose the intercept. But again, I'm going to tell it to display the equation and the R value. So you can see again, this actually gets the right equation. Negative 9.8t is basically the negative GT term, and the 29.4 is the V0 term. That's it. That's the entirety of the stuff you'll be using this whole semester. As you can see, we had a lot of other options for our trend lines, and we'll be exploring those throughout the semester, or using those throughout the semester. In 241, we used a lot of different ones. We used logarithmic, we used exponential, and we used polynomial. Okay, we didn't use moving average, but we used essentially all of them. So this process can be repeated over and over and over again, but you're usually not generating a formula. You're usually putting in data points from an experiment. Okay, does that make sense to everyone? All right, I'm going to save this so I can send it to you all. I'm going to save it in this document, but I'm going to do more options. This is for my D0, or excuse me, my L01B 242 class, which clearly I did not make. So I'm going to make a new folder, PHY 242 L01B. I'm going to put it in here, and I'm going to call it, whoa, went into the wrong one. So I'll put it in the wrong place. I don't care. But I'll send that out as an email to your SIS accounts. So now we've got that done. What I'm going to do is I'm going to make breakout rooms. It looks like we still have 12 students. I was hoping we'd get more by now, but we appear not to have. I'm going to make breakout rooms, and I'm going to let it choose them automatically. So when I do 4, it'll be 3 people per room. And if anybody else comes in, I'll just stick them in rooms as they go. I've now created them, and it's got you in a random assortment with your students, with your fellow students. I want you guys to go ahead and complete that lab and work with each other. I'm going to set it up. Let me do that now. I'm going to set it up where multiple participants can share a screen. So now you can actually share screen with your lab partners, and as you ask questions. So each of you should be doing the lab on your own, but you should be communicating with one another, see if you are getting similar results. That way nobody makes a mistake.